Okay, again, welcome. Today, our facilitator, our workshop leader is Kevin Dilley. He is with Explora here in New Mexico. He and Explora staff partner with us a lot at New Mexico MESA and helping us with curriculum output for teachers. And so he was very gracious in joining us today to be able to help with how to use microprocessors in design. I will turn it over to him, and I will be monitoring the chat. So any questions or anything, so that he has that opportunity to share a screen and not have to worry too much about it. If there's anything you need, please let me know. Please, if you're as interactive as possible, try to have screens on if it doesn't interfere with your with your Wi-Fi or your internet connection. That would be fantastic. It's really helpful, I think, for all of us when those are on. So like Anita said, we're not talking to the universe at large. But thank you, Kevin, for being here today with us. And with that, I will turn it over again for microprocessors, how to use microprocessors in your design.
Thank you, Ling. Yeah, great to be with you guys today. And let me just put out my thanks for you guys joining us on a Saturday as well. So I have a few things I want to share with you guys, a few things to show you. But before we do that, I just want to kind of just do a quick little poll of if anybody has used a microprocessor in any projects, or if your students have. So just a show of hands, or you can put it in the chat, yes or no. So I see a couple hands up. I see a no. So there's a few that have, a few that have not. And so we'll try and do a few things today. One is I'll talk a little bit about a simple microprocessor that you could use. That's a really kind of very easy learning curve for you if you've never used a microprocessor before. But I also want to open up a little bit to a discussion about people's experiences and challenges that they've had in using microprocessors in projects. So let me just start with a quick overview of what a microprocessor is. So a microprocessor is essentially just a small little device. It doesn't have to be small, but they're pretty small nowadays. What it does is it can control different types of components. So if you have something, so it's not a full-fledged computer necessarily. It could do a lot of things that computers do, but you can hook up other things to it. Like you can maybe hook up some lights to it, or you can hook up some servos or motors to it, or you can hook up some different sensors. Some of those things might be built into the microprocessor, but most often you have to have these other components that you'll hook up to your microprocessor, and your microprocessor is essentially the brains. You'll do some computer coding in which you tell the microprocessor that if this thing happens, then you want this other thing to happen. So maybe you have a button, and when you press the button, you want a light to turn on. So that's what a microprocessor is in essence, something that can control other components that you'll program to be able to do that. Now, there are lots of different microprocessors out there, and the people who have used them, I'm sure you've probably used different ones. So there are things like Arduinos. So Arduino boards, and within Arduinos, there's lots of different Arduinos, but they are one that's kind of pretty has a lot of capabilities that you can control lots of different things. You'll have to code it, but you'll have to hook it up to motors or lights or other things like that. So that one is one that I would say is probably more of a steeper, quite as simple as just plugging it in and going. That one, there's a little bit more that you have to figure out to be able to get that to work. On the more simple side of microprocessors, there are some things like microbits and circuit playground boards. So those are a few different ones, and there are definitely more out there. What I have today is I have a microbit that I have here, and I'm going to go through just a little bit of how to use a microbit, and this will give you a little bit of idea of things that you can do with the microprocessor and kind of what your students or your students would have to do to kind of get it up and running using something like a microbit. Okay, so we're going to start with a little tutorial here. Okay, so I'm going to put in the chat a website to go to. So it's makecode.microbit.org. And if you wouldn't mind going there, I'm going to share my screen and I'll show you a little bit about how the microbit works. Okay. And actually, before we do that, so if you've clicked on the link, that's fine. Come back to the picture right now. I want to just show you the microbit so you can see what it looks like here. So this is a microbit. It's a pretty small, you can see, you know, the size of it to my hand, right? It's a small little device. It's got a lot of different kind of components on it. And so on the front here, there are a few different things. There are two buttons, one here on the left, one on the right. So they're labeled A and B. So there are two buttons on it. And then there's this grid here in the middle of 5x5 grid of LEDs, so light emitting diodes on it. And on the back, it's got a lot of other components. It's got a speaker, it's got a microprocessor, it's got a cord, place to plug in a USB cord, a reset button. It has a compass on it. It has Bluetooth on it. So it's got lots of different components in it and capabilities for it. And so what we're going to do is we're going to do a little bit of coding to show how a microprocessor like this works. Okay, so let's go to that website that I put in the chat, makecode.microbit.org, and let me share my screen. And so this is, so it's a web interface for coding microbits. So this is like the homepage for it. It has, so mine, I have some different projects here across the middle of the screen. This is where if you create projects, this is where yours will be saved. Okay, so let's click on new project. So it's the big purple plus sign. And if, as I'm going, if I'm going too fast, if anybody missed anything, just holler or throw in the chat that you missed something, I'll go back to it. Okay, well, let's give this project a name. I'm just going to call it starter project. I'll just call it starter. You can name yours whatever you want. And this will take us to the editor for the microbit. So this is how we can do our coding with this. So for a microbit, you wouldn't have to download any special software. You just have to have a web browser, and there's no need to create an account. So this is something that you don't have to create an account. You don't have to download any special software for it. And that's not true for all microprocessors necessarily. Some of them are similar to this. But let me just orient you to our editor here. So you'll see here on the left, this looks like a microbit, right? So this is our simulator. And so this is why we can do this as a little workshop here. We don't need the physical microbit to be able to do the coding to kind of see what would happen when you run your code. We have a simulator that simulates it all. In the middle, there is a number of menus. If you click on any of these menus in the middle, it opens up to give you more blocks that we're going to be using for coding. Okay, and you'll notice they're color coded. Each menu is a different color, and the blocks from that menu are the same color. And on the right here, this is our workspace. This is where we're going to be doing our coding. Okay, and so this works on any device, right? So as long as it has web access, it can work on any of the different web browsers. So, you know, it works with Safari, Chrome, Firefox, any of those different ones. It works on those, okay? So what we're gonna do is we're gonna create a very simple code to start with. And one of the things that we'll talk about, or one of the things that you talk about when you talk about coding or about microprocessors are inputs and outputs. So an input is something that you would do to the microbit. So maybe it's pressing one of the buttons on front, and an output would be what is triggered by that input. So an output might be the lights, certain lights turn on. So maybe the input is I press some of the buttons, one of the buttons, and some of the lights turn on as the output. And so let's do that as our first code here. So let's click on the input menu. It's the pink one, the second one down. And we're going to drag over this one that says on button A pressed. We'll drag it over and put it into our workspace. And then we're going to grab from the basic menu, it's the top menu, it's the blue one, this one that says show LEDs. So I'm going to grab that and drag it over. And when I drag it over, I'm going to put it inside the on button A pressed block. And you'll notice if you move it around, it's highlighted yellow. If you put it inside, it'll kind of highlight yellow at the top of the on button A pressed inside of that, and you can drop it in there and it'll click in place. And so this show LEDs block is shows the different lights that are there on the front of the microbit, and you can toggle them on and off by just clicking on those different lights. So I'm going to just make a plus sign. And then I'm going to go over to the basic menu again, and I'm going to grab one that says show icon and drag that over. And I'm going to put that underneath the plus sign. So it's still inside the on button A pressed block, but underneath the plus sign. And this one has kind of pre-programmed pictures that you can choose from. So I'll just choose maybe an X. So I'll do a plus and then an X. And so if I then go over to my simulator, well, actually, if I read my code first, if I look at the code, I can see that if I press, we read it from top down. So it says on button A pressed, show the LEDs of the plus sign, and then show the icon of the X. So if I go over the simulator and you press the A button, click on the A button, it does that. Every time I press it, it's going to do the plus sign and then the X. So I can do it over and over again. Each time I do it, it's going to do those things. Okay. Now, one thing you'll notice is it's kind of fast how it does that. So if I wanted to slow that down, I would want to put a pause in between the plus sign and the X. And so I can do that in the basic menu and scroll down in the basic menu, and there is one that says pause. So I'm going to grab that and I'm going to put that in between those two. And this pause is measured in milliseconds. So 1,000 milliseconds equals a second. So if I want to make it like a second, it'll be 1,000. And you can do the drop-down menu, or you can highlight it and just type in a different number if you want. But I'll make it 1,000. So it's a second there. And so now if I go over to my simulator and press the A button, it does the plus sign, and then it pauses for a second, and then it does the X, right? So there we can see our simple first code of creating something with the microbit. Let's just add something more to this. Let's say I want it to do it more than once, right? Every time I click it, it just does it one time. So let's add a loop to it. So let's go to the loop menu. It's the green one, sixth menu down. And we'll grab this one at the top that says repeat 4 times do. I'm going to grab that. I'm going to put it in. I'm going to put it in a place. I'm going to make it so that it's inside the on button A press, but it has the blue show LEDs, pause, and show icon inside that. And so this, I can change the number to whatever number I want. And so we can see that if I press the A button now, it'll do that. It'll do it 4 times. 1, 2, 3, and 4 times. And there we go. So we can see how we can add pauses. We can repeat things. Okay. So this is the type of programming. This is just block-based coding that you could do. So it's very simple type of interface that you would be able to use with something like a microbit to be able to do this. And so this is using the input of the buttons and the output of the LEDs. And we can incorporate other inputs and other outputs if we wanted to. So if I click on input again, and I can grab another one of the on button A pressed blocks, you can see that it's grayed out. So anytime it's grayed out, it means it's not being used. And that's because there already is an input for the A button. So if I change this to the B button, then it's pink and I can add some other things in there. So feel free to do that. You can add something else in there. You can do from the basic menu, different things with the LEDs. You could show a number, you could show a string. So I'm going to grab show a string, put that in there. And so a string in coding is just letters, numbers, or symbols. And so we'll show the string instead of hello, I'm gonna type howdy maybe. So if I go over to the simulator and press the B button now, then it shows howdy scrolling across the screen. And so there's some simple coding for different inputs and some different outputs for it. Any questions so far as we go with this? And actually, I'm curious, has anybody ever used microbits before? Should have asked that at the beginning. Thumbs up if you have. If you have, okay, great. And so this simple stuff here is just for, having things displayed. And so it's pretty straightforward for these types of things with just using the microbit itself. And I can download this onto my microbit, and so I'd be able to use the actual physical device to be able to run things. So let me just do that really quickly. Let me just connect my microbit, and I'll download it. Sorry, just go through that quickly to get it connected, and then let me download. And so I'm downloading it to my microbit right now. So I connected my microbit so that the program recognizes it. I click the download button, and it's downloading right now.
So there's some questions in the chat.
Yeah.
Can you copy and paste an entire set of code?
So you can. So some things that you can do with that is if you want to duplicate something, if you right click on something, it will give you the option to delete things or add comments and such, but there's also the opportunity to duplicate. And so you could duplicate that whole thing, right? So I was able to do that. If you want to delete something, you can either highlight it and press the delete button. You can grab it and drag it back to the menu and it'll trash it that way. Or you can also right click on it, and then there's the option to delete the blocks. So there's that for copying code. Somebody else asked about learn the language. I'm assuming you're talking about learning different kind of coding languages. And so this is the block-based things I find is really easy for first-time coders. It's really intuitive. But if you have students that are kind of beyond that or want to learn a different code, text-based code, then there's the option for that. You'll notice in the top center, it says blocks, and then it says JavaScript. And so what you can do is if you click over to JavaScript, for example, what it'll do is it'll change your code into, give it a sec, into JavaScript. And then there's an option on the drop-down menu, you can choose Python as well. So you could do and you can go back and forth between these. So it could be a simple way for folks to see, how those blocks that they are maybe familiar with, what it looks like in a text-based type of coding language. And, you could do edits here. Maybe I'm changing this for showing the string to bye or something like that. And then when you go back to the blocks, it has all of those changes in it, right? So it allows us to see what changes in the text-based format look like in the block-based format and vice versa. Okay. Let's see, other questions? I
think they're mostly just comments.
Okay. Great. And so, yeah, and so we're using this interface here with the computer, and you'd plug in through the cord to be able to code the microbit. And there, mine's downloaded, and so I can press the buttons and see it working. But also, like I said, it has Bluetooth, so you could, on a device, either Android or Apple, there's an app for it, and so you would be able to connect through Bluetooth to the microbit and be able to code on a device, and then send it through Bluetooth to the microbit that way. So one of the nice things about microprocessors like this is that there are things like sensors, or you could connect to other components like motors. And so, that gives it a lot more capabilities if you wanted to use it in part of a project, if students want to use it for something. So let's say maybe students are using it in a project in which they want to have to have it sense how much light is, how much light there is, and depending on that, maybe it's going to move a motor and move that motor to a different place. So maybe it's something for somebody who's visually impaired, and they want to know if there's a lot of light or something shining, but they would have something physical that would change from that they would be able to tell. So let's look at how we can use the microbit as the light sensor. So one of the things that I talked about before was the LED lights here on the front, right? So if I press the button, it turns the lights on. So the way the LED works is you put some electricity into it and it gives off light. But the cool thing about LEDs is they work in reverse as well. So if you shine light on an LED, it gives off just a tiny bit of electricity. And so that means these LEDs can be used as a light sensor. So the more light that's shown onto this grid of LEDs, the more electricity is being created. And so you can measure how much light there is depending on how much electricity is created from these LEDs. Okay. Now, you may wonder if this could be used as like a solar panel. It doesn't create that much. There's just tiny little current that we can measure. Okay. And so to do this, we're going to try and use a different input. Okay. So on here, I'm going to actually, let's create a new project here, just so you can see how that's done. So we're going to click on the microbit picture on the top right. This is going to take us, or sorry, top left. This is going to take us back to our home page. And you'll see that your program is saved there. And let me just mention, so one of the things with microbit is where the programs are saved is kind of different maybe from other things. So your program is saved in your web browser. So it's saved in the cache of your web browser. So if you clear the cache of your web browser, all of your programs that are here will be deleted. You can download them if you want to onto your computer, but they're not saved on your computer automatically. They're saved in the web browser. If I'm on Chrome right now, if I then opened up Safari, it wouldn't have any of my programs in Safari because it's saved in Chrome because that's where I made it. Okay, so just so you know where things are saved. So let's click new project. And this one I'm going to call light sensor. Oops, maybe I'll call it light sensor. If I can spell it. There we go, light sensor. Great. And so for this one, we're going to use a different input. We're going to use an input of the light sensor there. So the first thing we're going to do is let's click on LEDs. It's the fourth menu down. It's like a dark purple. I'm going to grab this one that says plot bar graph of up to. I'm going to put it in the forever block. So the forever block is one that's not an input. It's just something that will always be running on your computer. And then let's go to the input menu. The pink one is the second one down, and scroll down towards the bottom or towards the middle there. And there's one that says light sensor. And you'll notice the shapes of these things kind of help us, the blocks do. This light sensor is an oval shape. And so I'm going to drag it over, and we'll see that the plot bar graph of 0 up to 0, those zeros are in oval shaped places. And so if I bring this up to that first oval, you'll notice the red dot there kind of gets tethered to it. And if I go too far away, it gets untethered. But I want it to be tethered, and then I'll just drop it in, and now it's in there. And so what we're going to do here is we're going to create a little bar graph of the light level. So the more dots that are on the screen means the brighter the light is that's shining onto our microbit. And we're going to change the range of it up to 255. So most of the sensors on the microbit, and most sensors in other places, it'll kind of usually be a range between 0 and 255. It's a computer thing about it. And so over on our sensor, we can see that if I have my it creates this little thing where I can change. If I grab it and drag up and down, it'll change the light that's simulated being shown onto the microbit. And you can see as it gets darker, fewer dots show up. As it gets brighter, more dots show up. So let me just download this to my microbit so that you can see it in action. Give it a sec. It's downloading still. All right. So there it is. So now it has the microbit here. It's shining light onto it, and you can see that on my screen, it has a number of dots. If I put my hand over it and kind of block out the light, it gets darker, and so fewer dots show up. So depending on the brightness of the light on it, it will show the different number of dots. So this is a way that we can have it so that it will be able to detect the light, and it'll give us an output. In this case, the output is our screen, the light's lighting up. The input is the light shown onto it. Okay. Now, the cool thing about the microbit is that when it's connected to the computer, you can actually get information from the microbit into your thing there. So you guys probably have underneath your simulator, it'll say show data simulator. And what we can do is if you click on that, what it does is it brings up a graph, and you can change the amount of light, and you can see how the graph changes, right? The level changing depending on the amount of light that is coming. And so this information is being recorded, and you could, if you wanted to, you could then, you can pause it and you can download it, and you'll download it as like an Excel file of like the timestamp, like every, so many ticks, and then the light level that it has. Now, the cool thing is with the microbit is when it's connected to the computer, you see on mine, it has this show data device. So that's showing the data on, let me click on that, from my physical microbit that is connected. Let's see. Oh, I have it paused. That's why. I was like, why isn't it showing anything? So I'll do record, and now it's showing data from my microbit. So as I put my hand over it, like the light goes down, take my hand off, it goes up. And so we can see how it's logging the data, the information from the microbit. So this is a microprocessor, usually has these capabilities too, right? It not only senses stuff, but it can give you that information that you can use it for something. Okay. So let me go back. There we go. So that is with the light level, how that would, how you'd be able to use that to get information from it. So this that we have here with the forever block, it's just showing a graph, or it's just, showing a graph on the screen, but we can use this information to trigger other things to happen. So let's create a new code for it instead of this bar graph. So I'm going to just drag this off to the side. And you'll see that when you drag something off to the side, it just goes gray. So if you want to keep something around but not have it in the code, you can do that. So when it's grayed out, it's not doing anything. What I'm going to do is we're going to create it so that we'll make it, when the light level is a certain brightness, maybe I'll make it have a happy face on the screen. And when it gets below a certain brightness, we'll make a sad face on the screen. Okay, so it triggers at a certain level a change in what is on the screen. Okay, so for that, we're going to go to the logic menu. It's the eighth menu down. It's like a turquoise color. And we're going to grab this one that says if true, then else, and put that inside the forever block. And so we're going to say that if the light level is above, let's say 125, so kind of about halfway. If it's above that, then show a happy face. Otherwise, show a sad face. So we're going to need to go back to the logic menu and grab a comparison block. Notice it's a hexagon shape. And so it will fit into this hexagon place right here. And we're going to compare the light level. So I'm just going to grab it here from my plot bar graph one. I'm going to grab the light level block, and I'll just put it inside this first oval. And I'll say if it's greater than 125 or so, right? That's about halfway. And we'll go to the basic menu, show icon. And I'll make it a happy face. And then basic menu, show icon, and make that a sad face. Okay. If I'm going too fast, just let me know. Also, if you're looking to replicate some of this code, you can just look and see what the color is of the different blocks, right? And that'll help you find which menu that it's from. And so here's my code. If I go to a simulator, I can make it brighter, or make it darker, it goes sad. As I make it brighter and it gets above 125, it gets happy. Okay. And so I'm going to download that to my microbit, and I'll check to make sure it works on that. So here you can see how we can get things to trigger something else to happen. All right, there it is on mine. Let me stop. So it is happy right now. As I put some shade over it, it gets sad. Happy, sad. There we go. So we can see how using some very simple code, we can get our microbit to try to change depending on certain sensors. And so there are lots of different types of sensors that we could use for the microbit and other microcontrollers. So in the input menu, there are some different things in here. It could measure the temperature. And so we could, see what the temperature is at different ranges. Compass heading. So if it's facing north or south or whatever. There's also sound level. So it has a microphone, so it could tell what the sound is. So we could use any of those here in place of light level, and depending on what that is, it could trigger the happy or sad face, or we could trigger anything else that we want the microbit to do. One last thing I want to show you with the microbit is how we can use it to control a motor, for example. Okay, so when we're talking about, let me stop sharing for a sec here so that hopefully you'll be able to see me a little bit better. So I have here a servo, and a servo is a type of motor that is a little bit different from a hobby motor. A hobby motor is one that it has two wires, right, for hooking up to a battery, and it's on or off depending on if it's getting electricity. So that's like a regular hobby motor does that. A servo is one that has 3 cords to it. There are 3 cords here. And the reason for that is 2 of them are just like a regular hobby motor that has for getting power to it. And the third one is the control wire. So a servo is a special type of motor that you can control what it does. So either control the speed that it does, so you can hook it up to a microcontroller and send some information to it to tell it to turn to a certain angle maybe, or to spin at a certain speed for a certain amount of time and then stop. So that's what a servo is. And so for connecting up a servo to the microbit, for example, you have to figure out where those wires need to be connected to be able to run it. And so to do that, there is a nice feature in the microbit. And so I'm just going to leave this code here for now. And I'm going to add an extension here. And if I click on extensions, this gives you the ability to add other menus to your menu in the microbit editor. So I'm going to add this one that says servos. And so you'll notice here that there are lots of different things that we could put on here, right? Some of them are from specific other products, and it'll give you specific blocks for that product. But I'm going to add the servo library, and we'll see that when it does, you'll see a new menu here. It's servo menu there underneath radio and above loops. And so with this, what I'm going to do is I'm going to grab an input block. Oops. Input, there we go, on button A pressed. And I'm going to go to servos. And what this will do is it has kind of 2 different things here. Well, 3, I guess, but positional and continuous. And that's because there are 2 different types of servos out there. There's a positional servo. So a positional servo is one that you can tell it a specific angle to turn to. And positional ones, they're usually from 0 just to 180. So it only has like a half circle range that you can tell it what position to be in. And then a continuous servo is one that will spin. It'll just spin. Okay, you can't tell it a specific angle to go to. It spins, and usually what you do is you tell it how fast you want it to spin, and you tell it how long you want it to spin for. So if you have like a robot, a little rover thing, you might have a continuous motor connected to the wheels, and then your coding for it to make it go a specific distance is you tell it to spin for 2 seconds, and that means it spins for 2 seconds and then stops, and that you'll have to figure out how far that is for it. Okay, so that's what a continuous one is. So let's look at a positional one. I'm going to grab a positional one and set servo to angle 90 degrees. Sounds good. Maybe I'll change that to 45 degrees. Okay, and you'll notice when I do that over in the simulator, it gives us a little simulation of the servo, and it tells us where to connect those wires to on the microbit. So this is really nice. So these wiring diagrams are really helpful in connecting different microcontrollers. Yeah. All right. And so I'm going to hook mine up to my microbit. And you'll notice here that on the bottom of the microbit, it has, these are called pins. So it has these places that you can connect to. They're kind of divided by some black space, but they're kind of gold places there that are conductive. And so on my microbit here, I'm going to connect it up like it has on the screen there. So I've got some wires here, and I'll plug them into the servo, right? So that I can connect them to the microbit. So I've got they're alligator clips on one end, on the other end is a male connector, and they will go into the female part of the servo. And I will connect them up to my microbit. Okay, so I just use the alligator clips to connect them. So it shows here on my on the wiring diagram here that one of them, the one here, goes to ground, the one on the other side goes to 0 pin, and then the center wire goes to 3 volts. Okay, and so let's get these here connected to ground, to 0 pin, and to 3 volts. So there we go. So there is it connected. And so now I'm going to just add one more input. Let me just duplicate this, change it to the B button, and I'll just make it a different angle here. So I'll just put it at like maybe 135. Okay, there we go. And so if you wanted to test it out in your simulator, once you have code like that, you would press on your A button and your B button, and you'd be able to see that the servo changes angles whenever you do that. So let me download this to mine, and we'll see if I can get mine to change. Still downloading. And there we go. So now let me, oh, not done. There we go. There we go. So you can see that as I press the A and B buttons, my servo spins to the different angle there. Okay. So this is how we can see that we can change the angle depending on which button is pressed. Now, if I wanted to, I can make it so that the light sensor controls that, right? So if I changed my code here so that instead of it showing, or it still could show the happy face, but maybe I would make it so that this angle would change depending on the light level. Okay, so if I downloaded that, then now I can see how I'm using the sensor to be able to change where the position of the motor is. So now instead of pressing a button, once it goes on here, give it a sec. There we go. Now that it's on here, I can cover up and it'll turn, and uncover it and cover it. And so it's changing depending on the light level, right? So that is an example of how we can use sensors and other components with a simple microcontroller to control those things. All right. So somebody in the chat had said they use microbits to do battle bots, right? And so yeah, so using these types of things, you can create lots of different projects with it. Okay. So that's kind of what I want to share with microbits. So it's just a very simple type of microcontroller. I find it's very easy for first-time coders to be able to use it. The components are pretty simple. And so it's one that I really like for that. I'm going to stop sharing my screen here. Oh, actually, before I stop sharing my screen, one other thing I want to share with you is that any of these projects that you're doing, you can share them with others. And there are lots of other projects here that other people have shared on the web. So, but if you want to share it, if you click on the share button on the top right, so the three dots with the two lines connecting them, you can share it. And so you would publish it to share. I'll just leave it light sensor, publish to share. And then when you share it, it creates a code that you can send, or a QR code. So you can send the link or have somebody use the QR code. And what it would do is it would bring up this project. So if you're working with students and you have some code that you want them to use, you could send them this code or have a QR code link. And they would be able to do it instead of having to drag and drop and recreate all of the different parts of the code. They could use this. Okay. And with microbits, if we go back to the home screen really quick, so if you click on microbits on the top left, you'll see your code is there. And if you scroll down, there's a lot of tutorials and other projects, some with videos to show, like being able to connect to other things, different games, lots of different, there's lots of different resources around microbits with projects and other peripheral things that it could plug into that can add other capabilities for it. Okay.
Kevin, there was a question about if they're ready to move on to the next, since this is beginner level, what's the next step for people who want to advance in coding?
Well, I would say I would say the next step up from microbits would be using Arduinos. So Arduinos have definitely a lot more capabilities than microbits do. There are a lot more kind of components out there that are built specifically for Arduinos, and the coding is like a text-based coding for the most part for Arduinos. And so I would think that is maybe the next step. If you still want to just kind of progress a little more, still using microbits, you could, I would say, switch over to coding using Python or JavaScript. So students could start to see what the syntax is, and that could get them familiar with being able to type out code and being a little more what's the word I'm looking for? Just careful about making sure you have the right syntax on it. I'm gonna stop sharing my screen now. Let's see.
Kevin?
Let's see. Yeah, go ahead.
Sorry, I was just gonna ask, you showed how to share the code. Is there, does the microbit website allow you to kind of like allow you a space where you could edit the code? Like say you and I could get on and be editing the code at the same time, or is that not available? Just wondering.
Yeah, not exactly of that where we're both looking at the same code and editing it together. There is a microbit classroom. So on the website, you can go to microbit classroom, and that has a place where like a teacher could create a classroom, all the students would join it. So you'd be able to see the code that they are creating. So you'd be able to see it. and you could send them like like some code that you've made, and they'd click on it and open it up in a new editor, and they would be able to edit their own. But they're not editing yours. They're like creating a copy of it, and they're editing on their own. So that is another thing, and that's a free thing. The Microbit Classroom is a free thing. But other than that, whenever you you share it, it sends them to it, and they create a copy of it that they edit with it. So you're not editing the same code. Yeah, and so for the rest of our time here, I wanted to open it up and just hear a little bit from you guys, so we can learn a little bit from each other. What are some experiences that you've had with microcontrollers? So let's start with microbits, since this is what we were talking about. Are there others who have used microbits, and what is your experience? If anybody wants to just comment on that, or if others have questions about using it that people could answer. Oh, so there.
I guess I could share.
Go ahead, Jim.
For me, like I'm from school in Los Angeles. I actually used microbit, at least parts of the curriculum, the online version, when I was had to teach computer science during the Zoom period. So I actually like, just like code.org and stuff, I like the online interface. For me, the always challenge is to take that next step from just the online, component, which is very valid, to actually get the physical circuit boards, because that costs money. So that's the challenge I've been having, trying to find the money to actually get the physical circuit boards and stuff. But some of those little curriculum bits, like for instance, the Battleship game with the microbits, I thought that was a very good way to teach how the XY axis works in computer science, which is not traditional math. It's actually the other corner. So it was a good way to teach that. So yeah, that's at least my experience. But I've used Adafruit before and other circuit board things like Mickey's and stuff.
Great, thanks, Jimmy. Yeah, there's a number of things in the chat about how to get them. And so one nice thing about microbits is they're not as expensive as Arduinos. So a microbit is probably around $15 to $20 for the microbit. They do come in classroom packs of 10, and that gives you a little discount on the price of it as well. The one problem with microbits is availability. Recently, because of supply chain issues, it's been hard to get microbits. So I've got some because I'm constantly checking to see when places have them in stock, because they get them in stock and then they're gone in like a week. So that's one drawback about them, is just kind of availability of them right now. So that is something to look for. In getting them, I mean, you could try and write some grants. I find that for like maker spaces and types of things like that, these are the type of equipment that grants are willing to pay for, things like that. Let's see. Somebody asked about C++. If anybody's using C++, is anybody using that? Maybe no. Yeah.
Sorry, it's Mila. I was the one that asked that question. Yeah, Arduino uses C++. So the jump from microbits, and even if they do see the Python or Java code, doesn't apply at that point. And I looked while you were speaking, sorry, for a converter of some sort, but it sounds like all hope is lost according to Reddit. So students, I feel, could apply the basic principles through the microbits and get encouraged by it. And if they are interested, potentially move forward with C++ if they're that motivated through other sources. Is that a good, or is that accurate, or am I on target with that, or that what's happening with C++ versus the one platform versus the other, yada, yada? Yeah,
I mean, there's also, and somebody put this in the chat as well, that Tinkercad can be used for Arduino coding. And so that could be one way to kind of get around that.
Yeah, I was just setting up my account for that too, actually. So.
Okay, yeah. So actually, why don't we move over to talk about different types of microprocessors as well. So microbits are pretty similar to somebody else had and I had mentioned earlier, Circuit Playground Express. So it's another type of, I should have brought one over with me, but it's similar to this as well. It's like a small device that's round, and it uses an interface similar to the microbit one. So it's block-based coding. It has some built-in lights that are multicolored. So, you know, so the LED lights here are just the red color, right? So you're not going to be able to get other ones. That one has a circle of lights that can be different colors. So that's kind of nice for that. But you can hook it up to other components like servos and things like that as well. And so that one's very similar. So between microbits and Circuit Playground Express, it's kind of your own preference of which one you would want to use. The only thing I would say is that I find that microbits have a lot more support materials. So like a lot more suppliers have other components that are specifically made for.
And then chips and cheese.
Could you guys just make sure you're muted?
And then a medium Pepsi. No,
And so that's the one thing I would say about the microbits is that there's just more things that you could use with it that are produced. Okay. And then for Arduinos, there are a number of different Arduinos and Arduino kits out there. And so those ones, it's a lot more of typing involved usually, unless you're using something like Tinkercad with it. And then there's a lot more, they don't have built-in things. So you'll usually have to have it go out to a breadboard and then out to buttons or lights or servos or things like that. So there's a lot of things. You can usually get things that you can plug them into. That'll make it easier to break out to those different components. So that is, I would say that Arduinos have a lot more capabilities, but it's a little bit more work to use them. What are other people's experience with Arduinos that use Arduinos? What would others say about them?
Smile again. Yeah, so I've had a group use it before COVID, and it's been hard to get the students picked back up again. And but yeah, so we have had success as far as, you know, connecting and getting lights to light. We just haven't gotten past that. And the biggest issue has been the fact that we need to plug these into a PC that has the Arduino program itself, where predominantly our students have Chromebooks. But luckily, my past librarian just slipped me some PC laptops that are luckily still operational. And so I think we can move forward still. And I'm hopeful. And so what I'm envisioning for myself is that I do get at least one microbit kit that is that's generous, and get some interest in it at all that way. And then if they want to push themselves more, then get into the C++. But that would be something where I would have to be very like, okay, freshman students, you're the ones that can experience the microbit, but then you need to move on to Arduino at some point, I think. I'm barely just processing all this while you've been speaking. You've just restructured my entire program.
A quick question. Why would you want to use C++? I just want to know why would you use that? Is that because your high school standard or something that's pushing you for that, or what?
I believe that's what the Arduino is programmed with. I'm not sure if there's I don't know if I can apply Python onto Arduino. I don't know, literally do not.
Okay, thank you.
So the Arduino coding language, I believe, is based on C++, but there are it's kind of a I wouldn't say hybrid, but it's like not straight C++. It's something that uses that as the basis for it. Yeah, so in using Chromebooks, so there are for Arduinos, there is a web-based interface as well that can be used with Arduinos. It's sometimes a little bit tricky getting it to go through to the Arduino. Especially, it depends on if your computers, you know, through a school, they'll have firewalls and other stuff. And so sometimes getting it to communicate through to the Arduino is tricky, and it's just on a case-by-case basis of what you would need to do that. So yeah, I find it's, and just in general, sometimes trying to hook up your Arduino to even a regular computer, there might be some things that you'll have to do to make sure it communicates really well or communicates at all with it.
Yeah, I think I heard that. Is that okay to say the name of the website that you think I could use to do that? Because I'm figuring
Yeah.
it would be a web-based platform.
Yeah, no, so it's through the Arduino, it's through Arduino. I'm trying to remember. I could look it up and send it
I
out.
appreciate that.
But we just have a couple more minutes left, I believe.
Okay.
Any other questions that folks have or comments before we sign off?
What's your experience with Raspberry Pis? We've used those extensively, actually, for several projects. Your thoughts?
Yeah, I mean, I love Raspberry Pis. I've done them before. I mean, it's essentially a mini computer, you know, and so one of the things about it, as opposed to like Arduinos, right, is that Arduinos, you have to hook it up to a computer, make sure it's hooked up, and then code it, and then you can set it, you know, disconnect it from the computer and then have it run whatever. So that's one nice thing about it. The Raspberry Pis, but with the Raspberry Pis, you would just, you know, hook up a keyboard and monitor to it and just use it as the computer to run the things.
Right.
So, I mean, I haven't used Raspberry Pis with like robotics types things, but I've done it for other projects, and I like Raspberry Pis. It's just it's a different type of experience I find the students have with that than a different microcontroller, because it's essentially like, here's a computer and we're doing stuff, making it do stuff, whereas other microcontrollers, it's really the microcontroller is something that I'm just getting some code into it and then disconnecting it from the computer, and it's its own little project that I've created. So it's kind of a different mindset, I think, in what it is, the projects that you do with it.
Thank you.
You're welcome. Time for one last question or comment.
Kevin, I just want to say thank you. I think you provided a great overview, and for me, I'm seeing this as a great workshop to kind of send out to our teachers as something to do right before the semester ends, to kind of show this video and have students potentially kind of go through what you showed. I think that for some of our students, they're going to be very interested in the servo component of what you shared today. So just thank you for sharing of your knowledge and expertise. I appreciate it. And thank you to everybody in the chat too, where there's been a lot of resources shared as well.
Yeah, thank you everybody for all of your participation in the chat and your attention and your cameras on. So appreciated. It is 12:45 Mountain Time. So there is a meal break for 30 minutes. At 1:15 Mountain Time, we'll reconvene. Room 2 will be, I just looked at it. I left my head. Integrate an app or website in your design. But take a look at the agenda, see if there's anything else you are interested in doing, or come back to this room, but you get 30 minutes. So we'll see you soon.